Hello, pre-algebra friends. This is our first video where you're actually going to be taking your notes at home, and then we're going to do the activities and some fun stuff during the classroom. So they kind of call this flipping the classroom. I've given you your notes. You should have them in front of you with a pencil. Please feel free to stop the video at any time you need to either catch up, or I ask you to do something on your own to complete the video, some of the notes on the video. So we're going to actually move on to section 1.2. We're talking about exponents and bases. We're talking about powers. Some of this is familiar to you and some of it isn't. I want you to look at this example over here. 19 raised to the exponent of 3. This is actually a repeated multiplication problem. I'm going to write the formal definition down for power because it's it's a little bit different. It is the result of repeated multiplication of the same factor. We talked about factors being the pieces that you multiply together to get a product. And this is a special type of multiplication problem. It's where you're repeating the same factor over and over and over again. So when that happens, we can write it in a shorthand fashion instead of writing the factor many, many, many times. And it looks like this. So in this particular example, the power is the whole thing. This is the example of a factor being repeated in multiplication over and over and over again. The power is made up of two parts. The base, which is the 19, and the 3, which is the exponent. The exponent tells you how many times to repeat the base as a factor. So, using this little shorthand method, we can make writing really long multiplication problems much simpler and more accurate. I might have already told you, I'll say it over and over again, mathematicians are really inherently lazy. We want something that's easy to write, but it has to be accurate. It's got to be correct. So this is one of those shortcuts that mathematicians mercifully have come up with. So let's talk about some special exponents. When you have an exponent of 2, we have a little nickname for it. Can you think of it before I write it down? If I say x is to the second power, what's another word or another way to say that? And it's squared. And the same way with the exponent of 3, cubed. What about 4? What about 5? Not so much. We just say 19 to the 4th power, 19 to the 5th power, and because we've got double digits, we will probably put parentheses around them there, and on and on. Okay, so let's talk about 0. Telephone. Hang on just a Okay, let's talk about our friend, the amazing, unique number 0. 0 is such a fun creature, and some of the rules don't apply to 0, or he's got special properties, so I always like to talk about him for a few minutes. Anyway, is it legal for 0 to be a base? In other words, can we take 0 to an exponent? I wonder. Well, what this means, according to our definition, is that you would take 0 and you would use him as a factor 3 times. And certainly we can multiply anything by 0. It just turns our product into 0. Is it legal for 0 to be an exponent? In other words, could we take 19 to the 0th power? I wonder. And that's a discussion for another time. I'll let you tell me what you think about that. You just think, is 19 to the 0 power, is that even legal? Can you even say that? Oh, I don't know. All right, let's look at a few examples. Evaluate. So there's some terminology that you did on your homework for last class. I want you to take x to the 4th, and I want x to have the value of 0.5 or 1/2, which means you're going to make your shell. You're going to plug in. Let's get another color here. You're going to plug in 0.5 for x, and you're going to evaluate it, which means you're really going to stretch it out and say, I need to take 0.5 and I need to multiply him 4 times. Now that's a lot of arithmetic. I'll get you started and then I'm going to let you finish it up. So 0.5 times 0.5, there's the first two. 5 times 5 is 25, and I need 2 decimal places. So here's the first, here's where I'm starting, 1, 2. So now I'm at 0.25 for this product. Now I need to multiply him 2 more times. 0.25 times 0.5. Let's do it. 5 times 5 is 25. Carry your 2. 5 times 2 is 10. Plus 2 is 12. And I need 3 decimal places. I'm going to start here. I'm going to go 1, 2, 3. Now, when I multiply these two, I just figured out that their product is 0.125, and I've got one more time that I need to multiply this. So I'm going to let you guys finish that up for homework. You can either stop the video now and do it now, or you can do it after we finish, but don't forget to finish up the final answer for this particular problem. Let's move on. Okay, now I'm going to give you a stretched out problem, and I want you to write it in our shorthand using an exponent. So 19 times 19 times 19. 19 becomes your base. Your exponent is 3. And this whole thing is called a what? Look at the very first vocab word. This is called a power. Now, isn't it a good idea that the mathematicians, the minds that be, came up with this? Because just think about 19 to the 19th power. Wouldn't that be a burden to have to write 19 times in a row to show them as a factor? That would be no fun, and also we might make a mistake. It'd be pretty easy to make a mistake. So this is a pretty good shortcut that I use all the time. Hopefully you will too. So this is 19 to the 3rd power, but we can also call him 19 cubed because he's got one of those special exponents of 3. All right, let's talk a little bit about formulas. Formulas are going to be a really important part of this year. I think formulas are important for you to know from memory, some of them. And the definition of the word formula, we're gonna come back to this. But I want you to think, before next class, I want you to think of a synonym, another word for formula. Your very best one-word synonym for formula. S-Y-N-Y-M-N. I can't spell very well. Synonym for formula. Let you think about that, and you bring that back to class. We'll fill this in as we go next time. All right, these are the important formulas that we're going to start out with that I'm going to expect that you need to memorize. So a square, let's draw a square. Please be drawing one on your notes. There's a little square. The way I let you know that all of its sides are the same by putting these little hash marks that show me all the sides are the same length, and a little bitty square down there to show that that's a right angle. Those are all the properties of a square. The formula for the area, A equals, you need an equal sign in a formula. A equals side times side. We don't use length and width for a square because the sides are all the same length. There's not really a length or a width. There's just a side. And perimeter, we're going to use perimeter is equal to, remember the word rim in the word perimeter. That means you're going around the rim of the square and adding all the sides up. So the word rim is kind of a clue. So the perimeter is equal to length plus width plus length plus width. But a shorter way to write it is 2 lengths plus 2 widths. So that takes care of a square. Let's do a rectangle. Draw our friend a rectangle. The way that we show which sides are the same in a rectangle, you've got these guys with one little hatch mark each, and then I'm going to put 2 hatch marks in the longer side. That shows they go together. And again, you can put a little right angle down in the corner. That makes it a proper rectangle. Area of a rectangle, length times width. Now we have two different dimensions. The length and the width are different, so we have to use two different variables. We can't use the S anymore. And perimeter, I mixed these up. Erase. Sorry, I gave you the perimeter for a rectangle in a square. Perimeter of the rectangle, 2 lengths plus 2 widths. So stop for a minute if you need to erase the perimeter of the square. I'm going to go back and fix that right now. When you're going around the sides of a square, they're all just sides. Side plus side plus side plus side. There's 4 of the sides. So you can write this, P is equal to 4S. And the last one we're going to talk about, and the last one that you need to have memorized, is the volume of a cube. Volume. I want you to think of a word, a synonym for volume. What is volume? What's another word that you can use? If I told you to talk to me about the volume of something, but you can't use the word volume, what would you say is the question? Formula. Volume is equal to, and because it's a cube, all of its sides, its length, its width, and its height are the same. So again, we can use side, and we're going to take it to the 3rd power, side cubed. So those are the formulas for this section. Got one more little, couple little problems here, and then we'll be done. A florist has a cube-shaped planter in which they want to plant flowers. Find the volume of soil needed to fill up the planter. Write your formula first and show all the work underneath the formula. So here's some important instructions. But the first thing, when I have a formula for area, for perimeter, or for volume, I draw a picture. So let's see if I can draw a planter. You might be able to do a better planter than me, but I'm going to draw a cube as best I can. This kind of helps my mind get around the fact that I'm dealing with a cube. There it is. And let's see, I need some flowers. Here come my flowers coming out of this. One more. So I've got a planter with some flowers in it, and you probably have a better looking picture than me, but I need to give you some information before you can solve this problem. I need to tell you that the length and the width and the height are all 16 centimeters. Without that information, you wouldn't be able to find the volume. So the first thing it says, write your formula first. All right, I think I will. Volume is equal to S cubed. And show all the work. The next thing we're going to do is plug in for S. We're going to make our shell. There it is. And I know what our S is. It's 16. So now I can go ahead and I can solve, and I can stretch this out and say, well, 16 cubed, that means 16 times 16 times 16. Now, if I had a calculator, I could hop on it, but let's say I don't. So I need to multiply these first two 16s together. I happen to know that that's 256 because I know some things. I need to multiply 256 times 16. I don't know what that is, so I'm hoping you can help me. That will be part of your homework. And you can go over here and do your arithmetic, or up here to the side. But don't do your arithmetic in this nice, neat problem that you're working step by step by step. One more problem, I think, on this page. A store is displaying copies of a new book. They're doing it in the form of a cube that they're filling in. It measures 5 feet on each side. Find the volume of the display. So I'm going to leave this for you to do as well for homework. You can draw your picture, put your measurement in. You can use the exact same format we did up here in number 1. And when you come to class, we're going to talk about how you do exponents on our graphing calculator that make your problems go really fast, and then you don't have to multiply 16 by 16 by 16 by hand. So remind me, and I'll show you, and we'll do that on the calculator. Okay, this concludes the first flip video lesson. Thank you for listening, and I look forward to seeing you in class.